Image is missing. Okay, fine. We'll read the question. A four-wheeled trolley car of mass 2500 kg runs on rails which are 1.5 meter apart. So, what do you understand from the first line? The entire mass is 2500 kg. So, weight of the trolley is 2500 into 9.81. Okay. So, this divided by 4, you will get weight on each wheel. Okay. 2500 kg runs on rails which are 1.5 meter apart is your x. Okay, and travels around a curve of 30-meter radius is your capital R, and wheel and at a speed of 24 kilometers per hour is your V velocity, changes into meter per second. The rails are at same level. Each wheel of the trolley is 0.75 meter is a small r in diameter, and each of the two axle is driven by a motor running in a direction opposite to that of the wheels. So I have to put a minus sign between two couples. Okay, at a speed of 5 times the speed of rotation of the wheels. So this gives your gear ratio 5. Okay, moment of inertia of each axle with gear and wheel is 18 kilogram meter square. So two wheels put together they have given moment of inertia. Okay, moment of inertia of each axle with gear and wheel, everything put together is 18 kilogram meter square. So two wheels moment of inertia is 18. Each motor with shaft, gear and pinion, this is your engine moment of inertia, is 12. Okay, that is only one. The center of gravity of the car is 0.9 meter. Therefore, here you have two motors, one for front axle and one for back axle. Okay, so that each is 12. Center of gravity of the car is 0.9 meter above the rail level. So this is your H. Okay, H is 0.9 meter. Determine the vertical force exerted by each wheel on the rail, taking into consideration the centrifugal and gyroscopic effects. State the centrifugal and gyroscopic effect on the trolley. So, given data, mass x is the width of the trolley is 1.5 meter, path radius is 30 meter, speed is 24 kilometers per hour, vehicle speed. So that is converted to meter per second 6.67. Diameter of the wheel is 0.75. So find the radius divided by 2 is 0.375. Gear ratio is 5. Okay. Moment of inertia of two wheels put together is 18. Moment of inertia of each motor, there are two motors. Front axle motor is 12 kilogram meter square and back axle motor is again 12 kilogram meter square. Center of gravity is at a height of 0.9 meter from the floor. Okay, clear? Now let's move into the problem. Weight of the trolley. So multiply by, let's read that. Weight of the trolley will equally distributed over the four wheels and will act downwards. Reaction force will act upwards in all the four wheels. Same. Okay. So W by 4, mg by 4. So 2500 by 4 comes around 6131.25 Newton of force due to weight will act downwards in all the four wheels, and the reaction force will act upwards in all the four wheels. The reaction only we are considering for calculation. So all the four wheels will experience a reaction force of 6131 pointing upwards. Okay, keep that in mind. Angular velocity of the wheel V by, so path radius divided by path velocity divided by wheel radius V by R. So that is giving 17.8 radians per second. Okay, the wheel rotation, angular velocity of the wheel. So my vehicle is going at a speed of 6.67 meter per second. Divide that by radius, you will get angular velocity. So angular velocity of precision, the same V by R. Here you have to put the path radius, 30 meter. Okay, so V by R. So 6.61 by 30, you will get 0.22 radians per second. Okay. Gyroscopic coupled due to the two pair of wheel and axle. Because moment of inertia is given for two wheels put together. Normally the formula is 4 times I omega omega p. But here I of the wheel is given two wheels together, wheel and axle together put together. Therefore it will come 2 times only. So 2 times of I omega omega p. But normally this is 4 times. Each wheel will give you I omega omega p. Therefore you are going to multiply by 4 for total gyroscopic couple. Here this special case, two wheels put together is having a moment of inertia of 12 kilogram meter square. I mean 18 or something. Okay. So therefore two pair of wheels are there. Each pair of wheel is having some I omega, I wheel, right? So of 18. Because two wheels put together is having 18, therefore two pair of wheels are there. That's why this is 2. Otherwise it should be 4. Okay. So that is why you have to understand the question when you are doing a problem. Otherwise you will put 4 here. If you simply by heart the formula, then everything will go wrong. So 2 times of I wheel, a pair of wheel and axle, everything put together is having 18 kilogram meter square. there are two such pairs, and where omega of wheel is just now you have found out 17.8, omega of precession is 0.22. So the gyroscopic couple due to wheel rotation is 141 Newton meter. Okay. The gyroscopic couple due to rotating parts of the motor. There is one motor in the front and one motor in the back axle. Correct? So therefore 2 times comes here. Otherwise engine will be only one. Here there are two motors. Two motors of moment of inertia IE, omega precession. Omega E is engine speed. Okay. That is 5 times of wheel speed. Gear ratio. Capital G is gear ratio. Omega W is wheel angular velocity. Clear? So that is 2 times of 12 kilogram meter square is the moment of inertia of one set of motor and gears. There are two such motors multiplied by 5 times. 5 is the gear ratio, 17.8 is the wheel angular velocity, omega precession is again same for both engine as well as the wheels. Okay, so now that is going to give me 470 Newton meter. Okay, so now in this question you have seen clearly that the motor is going around in opposite direction to the wheels. Okay, so net gyroscopic couple, wheel couple minus engine couple. So wheel couple 141 is the wheel couple, all the two pair of wheels. Engine couple is 470. Therefore, what happens? You are getting a negative value, minus 329. So therefore, negative sign will get opposite direction rolling, as we have discussed in the derivation. Okay. Due to this net gyroscopic couple, vertical reaction on the rails will be produced. Since CE is greater than CW, reaction will be vertically downwards on the outer wheel, vertically upwards on the inner wheel. Okay, normally in the derivation what you saw, outer wheels vertically upward reaction, inner wheel vertically downward reaction. But this is opposite direction rolling, therefore what you are getting, so for this is outer, inner, this is normal case. But when you are getting a negative answer, what will happen? Outer wheels will get reaction will be vertically downward on the outer wheel, opposite. Okay, this is wrong for this particular problem. Okay, so this is wrong. So you will get a downward reaction for outer wheel, upward reaction for inner wheel, opposite. Okay, rolling direction as reversed, vertically upward on the inner wheel. Let the magnitude of this reaction at each outer wheel or inner wheel be P by 2. P by 2 is for two wheels put together. Okay, no, each wheel, one wheel only. Okay, P by 2 equal to C by 2x. Why? This gyroscopic couple equal to P into x. P is the load on each wheel. Okay, P into x. X is the width of the trolley. Okay, so P by 2 equal to C by 2x. This I don't want to go into detail again. This is just taking moment. And then I am cross multiplying that x. So this, how did this come? P equal to C. C equal to P into x. Okay, so P equal to C by x. So P by 2 equal to C by 2x. So now do substitute the values, you will get minus 109.7 Newton is the gyroscopic load on each wheel with a minus sign. Okay, keep it as it is. Centrifugal force, find the centrifugal force, m omega square r, that is mv square by r. Force value is 3707 Newton. So overturning couple into distance of the center of gravity from the floor, h. In this case, it is somewhere around 0.6 meter, I believe, right? Fc into h, 0.9 meter. 3707 into 0.9 is 3363.3. Okay. So now this is equal to q by 2. Fc into h. So this overturning couple is balanced by vertical reaction, which are vertically upwards on the outer wheel and vertically downwards on the inner wheel. This is same as usual. Okay. Only the gyroscopic is getting reversed. So outer wheel reaction is vertically upwards and outer wheel vertically downwards reaction, inner wheel vertically upwards reaction. I'm saying it in the wrong way. Okay, let's read it carefully. Vertical reactions which are vertically upwards on the outer wheel, downwards on the inner wheel. This is as usual. Only the gyroscopic is getting reversed here. Okay. Let the magnitude of this reaction on each outer wheel is q by 2. So q into x is equal to couple overturning. CO is overturning couple, which is equal to q into x. X is the width of the vehicle. Okay. Q equal to q into CO couple overturning couple equal to q into x. Therefore q equal to c by x. So q by 2 equal to c by 2x. For each wheel you are putting this by 2. Okay. This is for each pair of wheel. If you divide that by 2, we will get each wheel. So C naught by 2x. So C naught is 3363. X is the width of the vehicle, 1.5 meter. So 3363 by 2 into 1.5 will give you centrifugal load on each wheel. So that is 1121.1 Newton, right? So now let us, I know that vertical force exerted on each outer wheel. Okay, so here this component alone is negative. Maintain the, no change in formula is required. Maintain the negative symbol and put it here. Okay, so W by 4 is 6131, that is pointing upwards because weight is downwards, reaction is upwards. Okay, so P by 2 is minus 109.7. Normally in the outer wheel it will be upwards, but in this case it is downwards. That's why you got a negative sign. Okay. So Q by 2 is as usual upwards. For outer wheel, all the three forces should be upwards. Reaction forces. Okay. Now obviously this will get subtracted. So don't, normally the book they are changing this formula, telling that this is downwards. Don't do that. Maintain the negative symbol and put it in the same formula. No need to change the formula. Okay. Put all the values into this. So 6131 plus minus 109. So the net answer is 7142.65. On each outer wheel, you are having a downward a force of 7142.6. Okay. Similarly for inner wheel, the default formula is this. Now same negative value you have to put here in the place of P, gyroscopic effect. Okay. So it will become plus. Don't change the formula as shown in the book. Same values, W by 4, P is minus. Actually it is wrongly typed here. This is 109.7. Same value should come here. Numerically all the values are equal, only the symbols are different. Same 109.7 is here. I think I have typed this wrong. So minus 109.7 Newton. Okay. So third one, Q by 2, 1121. Just same values, the symbols are different. Okay. So that comes around 5128.85 Newton. Right. So that completes the problem. Is taken from your Kurmi textbook. Right. Reaction on each outer wheel is 7142.65 Newton. Reaction on each inner wheel is 5128.85 Newton. Okay. Completes the problem. Taken from Kurmi textbook 14.1.